In the previous video for this week's lecture, we looked at Hadoop and gave an overview. So let's start with Spark in this part. So for this, and in fact for the rest of this week's lectures, I'll keep referring to the Spark official website because it's one of the few technologies which are, because of its popularity, because of its open source nature, is very well documented. To the extent that I'm going to keep referring to it, and I would encourage you to bookmark the website as well and keep referring to it. And you can learn so many nuances to specifics of how Spark went about and how you can get the most out of Spark. To start with, I'm going to start using the homepage and then work backwards from there. So let's go to the Spark homepage, spark.apache.org. So what you'll see is like a description of Spark. At the top level, you'll see that you can just download the entire software because it's open source, it's free. So you can just download it and play with it. Obviously, alternatively, you can just play with it on like the public cloud instances that's available for you. The good part is if you download it to your local machine, you can even set up like your own development environment like Eclipse or Visual Studio or like IntelliJ or something like that, and then get or PyCharm and get Spark integrated as part of that, and you can just use it for local development. The libraries of Spark are basically the four main categories which are officially supported by the Spark community, and then there are a whole bunch of third-party libraries. So Spark itself is it has a core backend which is meant for batch processing, and that core backend is today queried and accessed and processed using data frames, and then SQL is the preferred front-end language that Spark itself promotes actively. The reason being SQL is highly optimized. So there's a backend engine which is optimizing continuously how the SQL needs to be planned out in the backend. So that's why it promotes SQL and data frames. But then you also have access to the raw backend layers of data access below the SQL and data frames layers. We'll talk about that in the subsequent section in this week's lectures on Spark internals. The second library, which is extremely popular and useful, is called as Spark Streaming. The really big advantage here, before I get that, Spark Streaming is another alternative to Apache Storm that we spoke about just in the previous part. So you could use it for the CAP style workloads, right? Complex event processing workloads. The advantage that Spark Streaming has over, let's say, Storm or anything else is that for the most part, in fact for like 99% of that syntax, it looks exactly like batch. It's only 2 or 3 specific areas which you need to pay attention to make it streaming. So the advantage then is you could write a piece of code, you could test it out as though it's batch, like go through your software development lifecycle, figure out what you want to do, and then once you get that built, once you get that tested for batch processing, like you get it tested on your local machine's data, as an example. What then happens is that to make it streaming ready, you just have to put 2 or 3 specific syntax. Those are critical, obviously, but then the moment you put that, the rest of the logic remains the same for the most part, and that's very advantageous because you don't need to test it again, right? You don't need to worry about am I writing it correctly or wrongly, etc. So that's one of the reasons why Spark Stream became super popular. Machine learning, like I mentioned, the MLlib libraries that are Spark have become so mature now that it forms the basis for a lot of big data and machine learning today. Notice that scikit-learn, which is also very popular in the world of data science, is not big data ready. You could not take a scikit-learn algorithm for recommendation engines or logistic regression and run it on a cluster of machines. It won't give you the right result. Right? You would need the algorithms to be re-engineered using MapReduce, divide and conquer specifically, and the MLlib library has actually already done that for you. Last but not the least is something called as GraphX. GraphX is pertaining to a specific set of APIs and SDKs for looking at data from a relational point of view, where the relations are mapped out in the form of a graph. So a graph, in its simplest form, comprises of vertices and edges. The edges connect vertices together based on some definition of a relation, and then the vertices themselves are storehouses of state, typically. So the example being the parent-child relationship. So let's say you were modeling the entire population. You would model individuals as nodes or vertices. Whenever there is a familial relation, let's say parent-child as an example, then the edge connects those two vertices because the parent-child relationship connects them together. So that's an example of a graph. So to be able to process and analyze graph as a very specialized set of algorithms which are necessary for large scale. For small scale things don't matter, you can just use Python's graph processing libraries, but large scale you would need something like GraphX. Okay, so what is exactly Spark? We spoke about that in the last, actually lecture 1. Officially the Spark community itself looks at itself as a multi-language execution engine for data engineering, data science and machine learning on large clusters, right? While it says single node, I would say that if your data size is small enough to fit on a single machine and you're not going to see any volume increases there, just use Python, right? You'll actually get a lot more bang for the buck. It's a lot more popular, a lot less complex as well to worry about. Spark, obviously, the moment you go beyond a single machine, you have to think about really what does it mean to distribute workloads and things like that, and Spark just makes it so much easier. Multi-language because it supports SQL, that's definitely there. It supports Python, but it supports Java, Scala, R, and things like that. So we see some examples. So officially the website says simple, fast, scalable, and unified. You could agree or disagree, but then simple is like a reference to the fact that there is so much hidden behind the backend. As developers, you could just use very simple syntax and get started. And we'll see some examples of that. That's what simple refers to here. But in reality, it's more complex than just using Python, right? As an example. Nowadays, tooling exists in various development environments, so even that is actually becoming simpler and simpler as we speak. Fast, obviously, right? Spark was designed actually ground up for very large scale processing to be really done fast. Scalable, yes. Unified because 4 different types of analytical processing is all coming together, right? Batch and streaming data, SQL analytics, data science, and machine learning. So let's take a look at what Spark means by each of these terms. So batch processing is exactly like data processing that we typically want to do, both in terms of transformations as well as in terms of computations, doing aggregations and things like that. So for that, it officially natively supports Python, SQL, Scala, Java, or R as the backend. And because, like I mentioned, streaming is just batch with extra syntax at the front and the back. You could just use the same functional logic written in each of these programming languages for the most part, and then get your work done in streaming as well, right? So that's very, very powerful. So in effect, in the world of Spark, it does not matter whether the data is like fast in real time or large and slow, right? Or large and fast as well. So it doesn't matter, right? Whatever combination, it just works, and that's beautiful, right? In its simplicity. You just code up once. You don't have to worry about whether it's going to be run in batch or in real time manner. SQL analytics basically refers to the fact that it is not meant for OLTP, right? It's meant for OLAP. That's why it's suffixed with the word analytics. But effectively, whatever you could do with OLAP SQL on top of engines like Oracle, Postgres, etc., you could do it on top of Spark and do it faster, do it better, do it much more scalably. So today, if you look at the Spark SQL syntax, it's ANSI compliant. ANSI is actually the, I think, American National Standards Institute. That's what it refers. That's what it stands for, if I remember right. It basically prescribes standards for a variety of different technologies, and one of the technologies for which it prescribes standards for is the world of SQL syntax, right? The reason it did that is that multiple databases have their own version of SQL. Over a period of time, everybody was starting to pull the world of SQL in different directions. So all these database vendors came together and said, actually we need a common standard that we can all subscribe to, so that we know a developer who's written code in this standard can easily use any of these backends without having to rewrite the code. Right? That's the purpose of a standard like this. Excuse me. So ANSI standard became like a way to, checkbox that you're ready for prime time SQL workloads. So Spark built ANSI compatibility over a period of time now. There are two types of workloads that it says explicitly that it supports. One is called as dashboarding. Dashboarding refers to the fact that you could run an SQL query and expect answers to come back in interactive latencies. What I mean by that is, you're a human, you run an SQL query, you wait for the answers to come back up in your screen, typically in a dashboard. That's why it's called as dashboarding. You're not going to wait for 1 hour, right? You're not going to wait for 1 day. That just makes no sense, because you're waiting for some answers because you want to do something more from it. So that kind of an experience that you're looking for is called as interactive, meaning you run a query, or the query runs, and then it's supposed to return the result to you back in, let's say, 10 seconds, 20 seconds, 30 seconds. So that's the nature of query backend optimization that's possible. Now, this is not to say that any query that you write will run in interactive latencies. That's impossible to guarantee. But it is to say that you could use Spark in that setting, and people have done it before. And the way they do it before, or rather the way they've done it before, is by optimizing, making sure that the data tables are laid out correctly, structures are laid out correctly, stuff like partitioning and optimization, query optimization techniques are being followed correctly. So if you do all of that, you could use Spark as the dashboarding engine for you, perfectly fine, right? So much so, today, a lot of advanced visualization tools, which are basically tools that plot data for you visually in beautiful, pretty pictures, right? When they connect to backend big data systems, Spark is the compute engine of choice, right, for executing the SQL and coming back with the answers. Exactly for this reason. Ad hoc reporting, on the other hand, refers to the fact that you probably do not know what you want as an analyst. So you go about exploring data for you, and when you explore data, you start to query the data in various different forms. In which case you run SQL, you figure out, yeah, I'm not interested in this, I'll do some small change to it. I come back and change it. So you go through the series of ad hoc explorations until you find what you want. For that as well, you need interactive performance, right? So it's very good at catering to those kinds of requirements. And here's where the marketing gets ahead of what is reality in many cases. So whenever you hear a statement like, runs faster than most technologies, you should take it with a grain of salt. The advantage here is that because it's open source, there is credibility in a statement like this. The flip side is also that at the end of the day, Spark is also being promoted by a company, right, which is called as Databricks. So the creators of Spark, who were like a bunch of university students from University of California at Berkeley, along with their professor, they started Databricks to commercialize how Spark gets sold and to make money from it. So at the end of the day, even though it's open source, you will see marketing messages like this, so you should just take it with a grain of salt. But for the most part, these kinds of messages are true. You could definitely take that at face value. But then, what I always recommend to even clients that we work with or people that we want to work with that this technology is to just test it out for yourself, right? Be satisfied for yourself, and then you make decisions on top of it. Don't just take it at face value. Yeah. Okay. So that's the SQL Analytics class of workloads. The next class of workload is, of course, the data science done at scale. Think scikit-learn, but done at big data volumes. That's why Spark is useful. That's why we are learning about Spark in our big data course today. So doing things like exploratory data analysis, if you really think about it, right, it's actually just another class of workloads which require interactive processing. So you want to explore the data set, you're not going to wait for 1 hour, right, for each query that runs. You just want interactive responses so that you can just keep moving, keep making progress in your day. The best part is because the scalability is proven, you could do this at very, very large scale, right, petabytes, without having to worry about selecting a portion of the data or doing sampling and things like that. And then finally, machine learning. Machine learning by definition includes deep learning as well, includes reinforcement learning. Supervised and supervised does not matter. So TensorFlow, all of that is integrated. Spark ML already is there. Keras is actually having like backend implementations and things like that. So you could run machine learning at large scale and get that to work on Spark. In fact, there is even distributed deep learning hyperparameter tuning library that's called as Horrorword. It was originally open sourced by Uber, I believe, but then it's now available on top of Spark as well. So yeah, a lot of advantages to using Spark. The best part is, once you learn a syntax once, you get to use it for all these different types of workloads without having to relearn again. That's why it's called as unified, right? And that's, I think, one of the most profound changes that it's brought to the big data landscape. It's because of this. All right, so let's take a look at some examples. You might think I'm being lazy here by just using the examples instead on the website, but then because it's open source, because it's so popular, and there's so much credibility attached to it, which is a lot easier to just use these examples directly. So with the Spark SQL backend, by that I mean the data processing backend, it almost looks exactly the same as Pandas, right? You treat the data as structured in a certain form, typically relational. So you put it into a data frame, and that data frame imposes the row column based access format. The moment you get it there, you access it just like you would a Pandas data frame. So as an example, I've got my data here in a JSON file. So we spoke about JSON briefly, JavaScript object notation. So take JSON, read that, and for reading that you have out of the box libraries available to you. So you need to have something called as a Spark context. So we'll take a look at it in the next video. So you take the Spark context, you read the JSON file, and automatically you get a data frame. You don't need to specify what is in the data frame explicitly in terms of structure. The library will automatically figure out from the JSON, because the JSON is self-describing as a data format, right? So it tells you what the keys are, what the values are. So the data frame is available for you, and from that point on, you could query it just like you would query a data frame. So in this case, I'm just going to do a filter. The filter as the function name is where. Spark is very much designed to leverage the functional programming style of Python, and in fact that's what it leverages with SQL, that's what it leverages with Scala, and it's a very, very simple way to understand how to code like a series of data operations, but it's again very powerful in terms of what it manages to execute, and we'll talk about that backend as well in the next video. But yeah, what I'm doing here is I'm using the functional programming notation to chain a bunch of different operations, right? The first operation is a filter, where I'm using this filter with the keyword where, and I'm also referring to a specific column that I'm expecting in the data frame, because the JSON has it, which is called as age, right? And then using a value to filter, which is fine. What I get at the end of that operation is actually a data frame itself, and therefore I could apply further other data frame operations which are perfectly compatible with that syntax, right? So in this case, I'm applying a projection using the select keyword, just like I would with SQL, right, as an example. And what am I projecting out? I'm projecting out a specific column. What column am I projecting out? It itself is a nested field within a JSON data element, right? So if you remember our previous week's lecture, JSON is actually an example of a multi-structured format. So it's got key value pairs, but then it could also potentially have nested key value pairs where the data element has other fields within it. So in this case, name is the top order data element in that belongs to JSON, and within that there's another data element which is called as first, right? So I'm getting that data element, name.first, and I'm getting it for all potentially data elements in logs.json file. They could be multiple, and all those values get shown as part of the show command, right? So as you can imagine, up till the point that the select executes, it still continues to be a data frame, right? So that's why I'm able to chain these operations together. But finally, when the show executes, it's no longer a data frame because it needs to display to a screen. At the moment I emit to TTY, which is basically the screen, it's not a data frame anymore. So that's why I can't do anything more on top of it. So show is an example of what's called as an action. I'll come back to that. It's an important concept in the next video. Okay, great. So that's from a world of querying data and then doing simple exploration. We'll take much closer look at the syntax a little later. Likewise, what we just spoke about with exploring a data set using data frames, I could now start doing the next sequence of activities. Actually, let's do data science and come back to machine learning. So here in the world of data science, I've got a CSV file. We spoke about this in the last video, last week's lecture actually, comma separated values. And notice CSV here does not just refer to the fact that it's comma separated. It could be using other delimiters, but it's adhering to the CSV standard. That's how we should normally interpret it. And because the first stroke could have the header, I've given a parameter which is optionally set as false and set it true, so that the reader of the CSV file can know that I can use the first row as a header and figure out what these relation columns mean. So with that, I have the data frame. With the data frame, I now can select a bunch of features. Basically, I'm projecting those columns, and then I'm additionally doing a filter. So the filter here is very much similar to the where clause that we saw before. So now I have the filtered data frame, and that filtered data frame, I can then run a set of summary statistics. Again, very much like scikit-learn. So I get a bunch of summary statistics which tells me column distributions, null value checks, like what is the percentile distributions of values, things like that, right? So standard stuff which is very useful for me to explore the data set. And then I could additionally do other functions, other operations on top of the filter data frame. Okay, so that's in terms of analytics and data science. Machine learning, let's take an example of supervised learning. So again, I created a data frame, but here in the data frame I have two very special columns. One is called as a label, which is basically the dependent variable, and then I have a bunch of features which are basically independent variables. Notice that the features need not be just one column, it can be actually like an array of columns, doesn't matter. So with that I have the data frame created. The label is an important field, and typically in Spark machine learning, the label, which is the dependent variable, has to be like the first column, or at least it has to be addressable as a label column, right? And then you use that data frame to set up your supervised pipeline by dividing it up into training and test data, and there are functions available for it automatically. So random split is one such example. And then you could run your standard machine learning algorithms which are available out of the box with Spark ML lib. So you just import that and start using those algorithms on top of Spark data frames. You would not have any problems at all because it's already built for distributed computation on top of the Spark cluster. So in this case, I am initiating a brand new random forest regressor, just like I would use, just like I would do in scikit-learn. The num tree is initiated to 100, and that random forest is what I would fit on the training data frame. With that, I have my trained model, and then for generating the final prediction on the test data, I just call the transform function, once the test data once the predictions are executed, again it produces a data frame, a Spark data frame there is, and then so I can just call a show function to show the answers out. Right? So notice that throughout, in all these three examples, the syntax looked pretty much the same, right? Data frames, operations on top, and by the way, these are native operations, right? So I'm just calling native data frame operations, and then I'm finally getting answers on top of it, right? Whether it's machine learning or analytics, or data science, or just plain old data processing, doesn't matter. Great. Now let's look at other variants. So what we spoke about was Python. We'll use a lot of Python, by the way. So this variant is called the PySpark variant. SQL is the next variant we will look at in a fair bit of detail. We'll use this as well. So here, this variant is called a Spark SQL. So you could run SQL syntax, right, to pretty much do the same thing that we saw in the previous example with Python. But then here, the syntax is executed within a Spark environment using the Spark context. So when we take a look at examples, we'll see what we mean by that. The Spark environment itself is Docker compatible. Docker is like a container. We spoke about containers briefly in lecture 2. So Spark SQL can be run within a container, and the moment you run it within a container, you get the Spark SQL syntax, which is like a context which allows you to run Spark SQL statements without any other extra programming constructs. You just use straightforward SQL syntax. Select name.first, name.last, age, from, etc., etc. Right? Scala's there, Java's there, R also is available within the Spark ecosystem. Great. So with that, I'll just finish this video with one last mention. So Spark has had such a profound impact on the world of big data, and because it originated from the research lab at Berkeley, it had a lot of theoretical knowledge that was published in the form of academic research, and those all became seminal papers, right, in the field of distributed systems. So one of the foremost conferences which recognizes these kinds of research is called as SIGMOD. It's run by the Association of Computing Machinery, ACM. SIGMOD stands for Special Interest Group on Distributed Systems, right? I don't know the exact expansion of mod here, but yeah, it's a special interest group on distributed systems, databases, and things like that. So SIGMOD basically recognized, right, that Apache Spark is such a foundational piece of technology. It's had such a profound impact over the last 15 years that it gave this award, the SIGMOD Systems Award, to Spark earlier this year. It's a phenomenal achievement, but a truly well-deserved set of achievements. With that, I'll stop the lecture. Thanks.